Okay, moving on. We'll continue our topic of vectors here, number 16. It says, given the magnitudes of the vectors u and v and the angle theta between them, find the sum of the resultant vector, which is u plus v. Give the magnitude of the nearest tenth when necessary, and give direction by specifying the angle that the resultant vector makes with vector u. All right, that's important. Resultant makes with u to the nearest degree. So magnitude of vector u is 7. So 7 units in length will draw our vector. Magnitude of vector v is 13 units in length. And we've got a 22 degree angle between them. So let's go draw a picture so we can get a visual of these two vectors that we're looking at. So I'm going to go ahead and draw in vector u. So vector u, again, its magnitude here is 7 units in length. And then 22 degrees off that, we're going to draw in vector v, which is a little longer. Its magnitude is 13 units in length. And again, this is a 22 degree angle. With that said, we want to find the sum of these two vectors. So if you remember, we're finding resultant vectors. Easy way to show your resultant vector is to draw in your parallelogram. So in a parallelogram, opposite sides are parallel and congruent. So we'll go ahead and draw that in. So as we label that, this side here is 13, this side 7. We know opposite angles are congruent. And we also know, again, that the diagonal, let's go ahead and draw it in here. The diagonal from the initial point of both vectors is our resultant vector. Here's vector u plus v. So we want to find that vector. So when we draw in the diagonal, we form two oblique triangles. Now let's go ahead and label this angle right here. So we know this angle will be 180 degrees minus 22, right? Because we know any two consecutive angles are supplementary with each other, right? So remember, all four angles add 360. Opposite angles are always congruent. So with that said, this one's going to have to be 158 degrees. So this is a 158 degree angle right here. Right? That's that angle. And that means this angle is 158 degrees. I'm going to label it. So again, drawing a picture, getting a visual of what we have in front of us. Now with that said, this triangle right here, and let's take note of it, we've got a side, we've got an angle, and we've got a side. So here's a side, angle, side triangle. So that implies we can use the law of cosines to find any of the parts in that triangle. And we want to find u plus v. So using the law of cosines, as we pick a side, u plus v, the square of that side equal the sum of squares of the other two sides, 13 squared plus 7 squared, minus twice their product, 2 times 13 times 7, times the cosine of the angle opposite, which is 158 degrees. So we've now got our law cosine stated, and as we take the square root of both sides, we'll get what we're looking for. We'll get the sum of u and v. Right? We're getting ready to find its magnitude, its length. So u plus v is equal to the square root of 13 squared plus 7 squared minus 2 times 13 times 7 times the cosine of 158 degrees. So remember, it says round nearest tenth. So let's go ahead and put that in our calculator. Let's type that in. So as we do that, again, second x squared key, there's our square root key. We got 7 squared plus 13 squared minus twice the product, 2 times 7 times 13, times the cosine of the angle. Now remember, we need to make sure our mode is in degrees, so we got in degrees. But there's cosine 158, and if we hit enter, we get what? We get 19.66. So rounding to the nearest tenth, we get 19.7 units. So 19.7, there's the magnitude of vector u plus v, rounded to the nearest tenth. So we've got its magnitude. Let's go give its direction. So again, to give direction, it says find the angle that it makes, and let's draw it here. We'll do it in a different color. It makes with vector u. So let's find this angle alpha right here. So we want to find alpha. So we're going to give direction, right, with alpha. All right, angle between u and u plus v. Let's make note of that. Angle between u and u plus v. All right. So we find that. Now with that said, in this triangle, now that we have u plus v is 19.7 units, right? And we could label that now if we wanted. That's 19.7. Right? We have a side-side angle triangle. So again, I'll make a note of that. This is a side-side angle triangle. So I can use the law of sines. So let's use the law of sines. So to find alpha, I'm going to use the law of sines. And what's the law of sines state? The sides are proportional to the sines of the opposite angles. So again, we want alpha. We know that 13 divided by the sine of angle alpha will equal, we know side u plus v is 19.7 units in length, divided by the sine of the angle opposite, which is 158 degrees. And now what? We've got a equation to go solve. Let's go ahead and get rid of the fractions. So we want to clear it out. We can just go ahead and take the cross products. Right? We know that 19.7 times the sine of alpha is equal to 13 times the sine of 158 degrees. Right? As we clear that out. And then we can divide out the 19.7 on both sides, as we're trying to solve for alpha. So sine of alpha is equal to 13 times the sine of 158 degrees divided by 19.7, which means alpha, well, we'll need to use inverse, is equal to sine inverse of 13 times the sine of 158 degrees divided by 19.7. So let's go see what we come up with. So what is that? Let's go put that in our calculator. So as we put that in here, of course, second button and sine, there's sine inverse. All right, and let's type this in together. So we got 13 times the sine of 158 divided by 19.7. Close it out. So I got 14.3. So 14.3, which we're rounding to the nearest degree. We got 14 degrees for alpha. So what does alpha equal? Alpha equals 14 degrees. And what is alpha? Alpha is the angle between vector u and u plus v. So it's 14 degrees off vector u, our resultant vector. So we have its magnitude, and now we have its direction. So again, we found the resultant vector. All right. Let's move on. Let's do one more. Let's take a look at number 17. It says two forces of 415 newtons and 200 newtons act on a point. The resultant force is 486 newtons. Find the angle between these forces. All right, well, let's draw a picture of this. So we'll go ahead and draw a quick sketch of what we're given. So two force vectors. So I'm going to go ahead and draw in this first force vector. We'll call this one here 415. Here's force 1. We can give it a name, 415 newtons. And then we got another vector that's force 2, F2. We'll call it the second force. It's 200 newtons. As we use, again, our parallelogram method, let's go ahead and draw in opposite sides, parallel and congruent. So we go ahead and label these sides. And we know the resultant, right, is this diagonal right here. So a diagonal forms our resultant vector. So there's F1 plus F2, which is equal to, they gave us that, resultant force is 486 newtons. So as you look at it, we want to find the angle between the two force vectors. So what we're looking at eventually is to find this angle right here. So we're going to find that angle, and we can call that angle, what, alpha if you want. So we're going to find alpha eventually. So again, alpha, let me make a note, equals the angle between the forces. Now, first thing I'm going to do is go back to my drawing. Now, in my drawing, what do I have in my drawing? I have two triangles now when I form that diagonal. And we've got a, what? Side, side, side. Here's a side, side, side triangle. And a side, side triangle, I can use the law of cosines. So let's go ahead and find the angle right here. Let's find theta. I'll call that theta. So what does theta equal? So let's find theta using our law of cosines. So let's go ahead and show our work here. We're going to find angle theta. So side opposite angle theta is 486. So 486 squared, pick a side, square of it, equals the sum of squares of the other two sides. 200 squared plus 415 squared minus twice their product. 2 times 200 times 415 times the cosine of the angle opposite, which is theta. So again, I'm trying to solve, right, for theta right here. So here's theta. Let's get it by itself. So we're going to move these terms over. We know how to solve it. So that implies what? 486 squared minus 200 squared minus 415 squared equals what? Negative 2 times 200 times 415 times the cosine of theta. And then we can divide out the coefficients, right, on both sides. Right, if we're going to solve for theta, we got to get it by itself. So we'll go ahead and do that. Let's go ahead and divide both sides by that. All right, and what happens when we do that? When we divide both sides by that, we can go ahead and cancel out these. So we end up with what? The cosine of theta holding the value of 486 squared minus 200 squared minus 415 squared divided by negative 2 times 200 times 415. And then at that point, we can use inverses. We know theta equals cosine inverse of this fraction. So 486 squared minus 200 squared minus 415 squared divided by negative 2 times 200 times 415. So again, I'm ready to put that in our calculator, right? See what we come up with. So let's go type that in our calculator together and see what we get. So on our calculator, let's clear out the last problem. We need the second cosine button. Be careful, we need a parentheses around the numerator. 486 squared minus 200 squared minus 415 squared. Close the numerator parentheses, divided by denominator, put it in parentheses. Negative 2 times 200 times 415. Close it out. Close out that. Hit the enter button. I get 98.3 degrees. So again, I got 98 degrees for that. So 98 degrees, let's go back to our drawing, that's theta. So this is equal to approximately 98 degrees. Now with that said, we can go back in here and label that. So that's 98 degrees. So now, if I want to find alpha, well, that implies what? That implies alpha, and again, I'll draw it in red. Let's put it back the same color. That implies alpha equals 180 minus 98 degrees, right? So again, let's looking at finding the supplement. So remember, opposite angles are congruent, right? And we know any two consecutive angles are supplementary of each other. So it's going to have to be the supplement. So it's going to have to be 82 degrees, right? So alpha is 82 degrees. So the angle between the forces is an 82 degree angle between those forces. So a good application of vectors.